So today start our class 12 physics syllabus. So mainly here we discuss the concept of physics, solving some numerical, mainly focus in that lecture is only board exam, not only totally focus on board exam, we are also solving some numerical that's an competitive exam also. Okay, so if you want to clear the board exam or competitive exam, the concept is very important for solving any type of numericals. Okay, so in that lecture series we just focus on concept of solving some numerical and some derivation. Okay, so first we discuss here that syllabus breakdown of class 12. Okay, so there is two part A and part B. So part A and part B. So part A mainly here we study electrostat, current electricity. Okay. Third is magnetism. In magnetism, there is some application of magnetism. Okay, Ampere's law, Biot-Savart's law, they are in magnetism portion. Okay. Fourth is EM theory. That's very important. Electromagnetic theory. That's mainly there's the four parts in part A. Okay, and part B here we study optics. In optics we study the wave optics and optical instruments. Okay, and basics of optics and refraction, reflection, the basic. Okay, you all know that the lens formula, and then is the wave optics, Huygens principles, diffraction, interference. These are in optics part. So here wave optics, Huygens principles. Okay, refraction. Principles. mm, These are in optics portion. And next is that EM theory. Sorry. Next is that modern physics. Modern physics. That is Einstein theory. Einstein theory and Einstein equation discuss mainly in this portion. Okay. Next we discuss some atoms and nuclei, concept of what is atoms and what is nuclei. Okay. And last is semiconductor. Actually, these are the mainly application portion. So these are whole in our class 12 syllabus. Okay, so today start electric charge and field, and these are chapter in electrostat portion. Okay, so now we start electric charge and field. We start electric charge and field. Okay, so here that concept came. So that's are mainly in electrostat portion. Okay, so static electric means static charge. So here the charge is static. A static charge means charge is not moving. Okay, and we know that suppose what is the charge concept? We all know that all bodies are made up of very tiny particles called electron, proton, and neutron. Very some tiny particles called atoms. Okay, and nuclei also. And there are mainly some properties. If the two charges are placed very near to each other, there's something happen. There's some force introduced here. So first come deals with the electrostat, the study of force, field, and potential. So here that is electrostatics. It mainly deals with the force, study of force, Okay, so this force is obviously the electrostatic force. Electrostatic force, static force. Okay, and if a two charges are close very near to each other, their two charges experience some force. Okay, that's called electrostatic force. Field, very important. Okay, and some potential. These are all in electrostatic portion. Okay, so all body are made up of very tiny particles. It's called atoms and also called molecules. And we all know that electron number and proton number are the same. Okay, so if the body lost electron, so means the gain a positive charge, and if the body is gain electron, we get a negative charge. Okay, suppose take a example of sodium. Take example of sodium in A. We know that atomic number sodium is 11. Okay, so if the atomic number 11, so that means the electron number also 11. Electron number also 11. So electronic configuration of 11, that is 12, 2, 8 and 1. So last cell contain only one electron. For stability configuration, if sodium lost one electron, if the sodium need to lose one electron, so sodium get 2, 8 and lost electron means electron is a negatively charged, and we all know that all body made up of very tiny particle and they are in neutral. For neutrality reason, so if a one is lost, so gain a positive charge. Okay, so similarly, if we take a chlorine Cl, so atomic number is 17, so electronic configuration is 287. So last cell have 7 electrons. So if one electron gain chlorine, and chlorine have stability 288, chlorine have stable, so means chlorine gain one electron, that's why chlorine have minus charge. Okay, so positive and negative, a configuration look like that. If a loss electron means gain positive, okay, and gain electron means gain ions. These are ions. Okay, so we know that the mass of electron. So mass of electron is very small. Okay, so mass of electron, that is 9.1 into 10 to the power minus 31 kg. That's very small. Okay, that's why it deal with very tiny particle. Or mass of proton, that's also very small. 1.7 into 10 to the power minus 27 kg. Okay, so here we see that this particle, and this particle is a very tiny particle, so that's why it deal with here the microparticles. Okay, so you remember that in class 11 we deal with a macro particle. Okay, and here we deal with very tiny particles called microparticle. Okay, so actually the name come from electricity. The electricity means a very tiny particle electron move from one end to another end of a conductor. Okay, so the electricity, the very important concept, the electricity is coined mainly they come from the Greek words electron. Okay, the basic theory, they name come electron. Okay, so that's the basic idea about know what is the electron, what is that proton. So now here we study the force. Study mainly the force. Study the force, and this force. How to study the force? So we take some experiment. We doing some experiment. Okay. So experiment. Okay, so first we take a glass rod. Okay, take a glass rod. We take a glass rod. Glass rod. Okay, and obviously glass rod have number of electron number and proton number be the same, positive charge. If glass rod have 4 positive and 4 negative, means they are in equilibrium condition. Okay, so now we take a silk cloth. Suppose we take a silk cloth here. That is called a silk cloth. Okay, so silk cloth have all same concept. Plus 4, neutral condition means neutral means that is a positive 5 and minus 5 we get a 0. So that's why these are called neutral. So if positive proton, 5 proton and 5 electron, if I get it, added these two, we get a 0. Number of nucleon be the 10, but number of charge here is 0. Okay, so that is a negative here. Okay, so that's a silk cloth. This is a silk and that is a glass one. Okay, so you know that silk have higher electronegativity. Silk have higher electron affinity. Silk have higher electron affinity. That's why after rubbing, silk acquire these minus. Okay, these from glass rod to silk rod. And if that silk gain negative, so that's why these plus and minus cancel. Okay, these are neutrals. So silk have only minus charge here. Okay, so glass rod, same concept. A loss electron means obviously glass rod loss electron means we say the loss electrons so gain positive here. So these are all positive here. So after rubbing, due to a silk have high electron affinity than glass rod, so obviously that silk have more tendency to accept that electron. So after rubbing, the glass rod have only positive charge and silk rod have only negative charge. So after rubbing, the glass rod, okay, have only positive charge and silk have only negative charge. Okay, and one thing here, this experiment doing performing in very dry condition. Okay, the humidity is very low because that the humidity very low is the water particle in air is very low. Okay, so that's why the loss of charge here that is almost negligible. Okay, and same glass rod we taken here. We take the same another glass rod, doing same treatment, rubbing with silk cloth. So after rubbing, this glass rod have all points. Okay. So now if two glass rods very near to each other, we see that. So after rubbing, we see that this green color rod move left side and blue color rod move right side. So we know that the basic concept is the like charge they repel each other. So the like charge they repel each other means there is a force and this force is called repulsive force. Repulsive force. Okay, there is a repulsive force here. Okay, so now and next we discuss what is force. Okay, and what is that force name and what the force came from. So we're doing another experiment. We take a plastic rod. Take a plastic rod. Okay, and rubbing with wool cloth. Okay, woolen cloth. So after rubbing, the plastic rod gain all negative because plastic have higher electron affinity than wool. So that's why uh, plastic have higher electron affinity than wool. So these plastic have all negative and woolen have all positive. So if two plastics are very near to each other, we get some repulsive force because we know that like charge they repel each other. Okay, so now if these glass rod and plastic are very close to each other, next we're doing the glass rod and plastic rod. So okay, here a glass rod, suppose we take that is a glass rod, and here we take a plastic rod, and these two rods, suppose say that is a glass rod have positive and this is a plastic rod is negative. And here we see this glass rod move towards the plastic rod and this plastic rod move towards the glass rod. And here we see that attractive force. Okay. Previously see if that the two like charges rod, so that's why there is a repulsive force. And here to unlike charges rod, here we see that there is an attractive force. Okay, and later we know that this force is called electrostatic force. Okay, that repulsive force and attractive force, that repulsive and attractive force is called electrostatic force. Static force. Okay. Why this called electrostatic force? Means the charge are not moving. The charge here are not moving. So that's why this is called electrostatic force. Okay. So now we discuss another instrument is called electroscope. Called electroscope. What is electroscope? So electroscope very easy. Okay, the concept is, suppose we take a ball, metal ball, this look like this, to end up metal ball here, and these are all in metal. Okay, these are obviously a good conductor of electricity. And if a very suppose a glass rod touch the metal ball, touch the metal. These are the obviously glass rod. Okay, these are the glass rod positive and touch this metal ball, and we see that this metal ball have positive charge. Okay, so after touching we see that very carefully these rod these two end of the rod are moved in that case. Okay. So actually look like this. End movement look like they are spread. Okay, why? Because these end or two legs have the both are the same charges, so that's why there is some repulsive force. There is some repulsive force, and due to that repulsive force, these are moved in away from each other. Okay, so if that is take a metal ball and same, and if I touch with a plastic rod here, these are the plastic, and suppose this plastic have all negative, and this metal ball also have negative. So these are the negative. Obviously, these are the two end of that metal legs have both have the same charges. So that's why there is some repulsive force here. So these legs move. They are the spread. Actually, they are the spread. Obviously, here also some repulsive force. Repulsive force. Okay. So that is the instrument. This instrument is called electroscope. This instrument is called electroscope. Okay. Next concept we discuss conductor, insulator, and semiconductor. So next we discuss conductor, insulator, and semiconductor. What is conductor and what is insulator and what is semiconductor? Conductor means all metal have conductors. First, take an example, that is all metal have good conductor, because the current flowing through the conductor is very easy. Okay, so that's why it's called a good conductor. Okay, means a metal have good conductor, very easily current flow, very easily current flow. Okay, that's why it's called a conductor. Take some metal, any metal have a good conductor. Okay, and insulator is a very poor conductor. Insulator means very poor conductor. Mainly they do not conduct electricity. They do not conduct electricity. So that's why these are called very poor conductor. Take an example, plastics, wood, plastic, wood. Okay, these are very poor conductor. So that's why these are called insulator. Okay, very weak flow of electron here. Okay, mainly the flow of electron is very weak. Here, flow of electron is very, and here the flow of electron is very fast. Flow of electron is very fast. And semiconductor is the in between conductor and insulator, a midway between the conductor and insulator. Sometimes semiconductor behave as an insulator, sometimes semiconductor behave as a conductor. Okay, so that sometime means that is a 0 Kelvin. So at 0 Kelvin, semiconductor behave as an insulator. At 0 semiconductor is an insulator at 0, and greater than 0 Kelvin, obviously semiconductor behave as a good conductor. Okay, so that's why it is a semiconductor, and that is the atomic configuration. Suppose we take an example, semiconductor. Silicon is a good semiconductor. So atomic number is 14. So electronic configuration is a 2s, 8, 2, 8, and 4. Okay, so in conductor means a good conductor. Obviously there is a metal. So metal have last electron number is 1, 2, 3, and insulator means non-metal. Sometimes these are also a non-metal, also a good current of electricity, but I take a non-metal is very poor. Maximum portion chances non-metal is a very poor conductor of electricity. So last cell electron number, that's the last shell electron number, 1, 2, 3, and here last shell electron number, that is 5, 2, 7. Okay, That's the concept of semiconductor, insulator, and conductor. Okay. So now we discuss that induction process. So what is induction? Next we study the concept of induction. Okay, and the induction, conduction, radiation, we know that. So first we study the mainly our syllabus are in induction process. Okay, so we take two metal ball. One, two metal ball, and that's two metal. Suppose say that is A, and this metal ball is named as B. And if we touch these two metal ball, next we touch these two metal ball, A touch with B. Okay, touch two metal ball, and we place a glass rod very near to that is A and B. Keep in mind there is some gap here. Okay, there is some gap here. Okay, there is some gap. Okay, so if two glass rod are very near to that these two metal ball, and we see that suppose metal ball A and metal ball B, they touch each other. See two metal ball. Okay, and here is a glass rod, all positive, and near the portion of the metal ball, actually near that with the glass rod, that is a glass rod, you see the negative charge is accumulated on left side here. If the negative charge is accumulated left side, obviously that positive charge also accumulated on the right side. Okay, so that is the A and B metal ball. Okay, and now if we separate these two, if we separate these two metal balls, there is some gap if I separate these two. So now diagram is look like this. A and B, see very carefully this negative here, positive here. Obviously there is a glass rod here. Okay, now we remove that glass rod. Next step is we remove that glass rod here. And now these charges are fully distributed through that A and B. Let's say fully distributed on minus, and here distributed with plus, fully distributed. And this process is called charging by induction. This process is called is called charging by induction. Charging by induction. Clear? What is induction? Before that, before induction process, we see that neutral condition here. Two balls have equal number of positive and negative charge, and after doing that experiment, and we see that A ball have only negative charge and B have only positive charge. So that's why this process is called charging by an induction. Okay. Now, if same concept, if I take a metal ball here, okay, and suppose we bring a plastic rod here. Plastic have negative, these are plastic rod and positive on that left side, and negative, obviously there is a far from this plastic rod, that is the negative is here. So now if we connected the negative to the earth, negative to the earth, okay, negative to the earth, see very carefully, these all negative are going towards the earth, because earth is a huge reservoir of negative charge. Okay, this is called ground. It is a huge reservoir of negative charge. Okay, so all are these negative move towards the ground, and that is finally this metal ball have only positive charge. This process also called induction. This is another process. This process also called induction. And here we see that before that this experiment, we see that this metal ball have neutral condition, means equal number of positive and negative charge. Now after that experiment, we see that the metal ball have only positive charge. Okay, that's why these are called charging by induction. Okay, next we discuss additivity of charges. So, additivity of charge. Additivity of charge. Yes. Okay. So actually, charge mainly the follow the additivity is a superposition principle. Just simple algebraically added. If a total number of charge, just be simple algebraically added. Suppose the total charge, say that is a QT. That is means Q1 plus Q2 plus Q3 and so on. Okay, these are simply algebraic addition. These are the simply algebraic addition. Okay, it's simple algebraic addition. Next we discuss charge is quantized. Okay, so the SI unit of charge is coulomb. Okay, keep in mind the SI unit of charge, SI unit is coulomb. The name of the scientist Coulomb. Okay, that's why the SI unit of charge unit is coulomb. The charge is coulomb. Okay, next is charge is conserved. Charge is neither created nor destroyed. Okay, so means that is a atom are neutral. Atom are neutral means charge is conserved. So next we discuss charge is conserved. Yes, sir. Conservation of charge. Conservation of charge means charge is conserved means atom are neutral. Why? This atom are neutral. Atom on neutral condition means equal of positive negative charge. So positive charge is proton and negative means the electron. So rubbing are transfer of charges. So rubbing means here if we take a suppose a glass rod. Before rubbing, glass rod have 4 positive and 4 negative. The number of nucleons, if I ignore that is a neutron, so there is a 8 particles or 8 particles here. So after rubbing, this negative also turn into a plus. So that means here also that 8 particles here. So before rubbing, the glass rod have 8 particles, and after rubbing, glass rod have also the 8 particles. Say that 8 electron or 8 charge particle. After rubbing, glass rod have 8 charge particle. 8 charge particle. So that's the total number of charge particle are same. So that's why charge is neither created nor destroyed. The equal number of charge is the same. Okay. So next is the conservation of charge. The conservation of charge. And this is called conservation of charge. Okay. Next we discuss the quantization. This is called a conservation of charge. Next we discuss quantization. What is quantization? And the name suggests quantization means that quanta means very small. Quanta name suggests that is a very small. So flow of charge in a conductor, you see the very carefully and listen that minutely, focusedly. The charge is flow of charge is not continuous. It is a discrete value. Flow of charge is not continuous. Mainly, the flow of charge in conductor is not continuous. That is not continuous. Is a discrete value. Is a not continuous. Is a discrete value. Discrete value. Okay. And these are multiple of the certain elementary charges. The discrete value means the multiple of certain elementary charges. Certain elementary of charges. Okay, and that is the quantization concept came from. And we see the very carefully. Suppose the charge is q. Okay, and n be the quantum number. Okay, or call suppose or call n equal to plus minus 1, plus minus 2, plus minus 3, and so on. And here in case of electron, that E is called elementary charges. This is called elementary. These are the elementary charges. Okay, charge. These are the elementary charge. Value of E is 1.6 into 10 to the power minus 19 coulomb. Okay, so the charge have only discrete value, so that is called charge. Quantity is quantized. So charge have discrete value. So charge have discrete value, some discrete value. Okay, so that's why the quantity is quantized. So the quantity of charge, so quantity of charge is quantized. The quantity is quantized. Okay, so next class we discuss that Coulomb's law. So here I discuss the basic concept of what is charge and some properties and some additive nature of charges here. So thank you.